Another key part of the ITS research program are the applications that will enhance mobility, as well as those safety applications that rely on infrastructure interactions, such as with traffic signals. Here to talk about these topics is Jeff Lindley, Associate Administrator for Operations with the Federal Highway Administration. Since August 2008, Jeff has led the direction of the development and delivery of federal highway policies and programs focused on reducing congestion and improving operations. A longtime veteran of FHWA, he has served on a variety of leadership positions, including Associate Administrator of Safety and Division Administrator for California. He also happens to be an engineer. So he brings a rare combination of administrative and technical expertise to the table. So please join me in welcoming Associate Administrator Lindley to the lectern.
Thank you, Greg. And I'd like to also offer my thanks to ITS America and the other organizers of the World Congress for the opportunity to speak to you this morning. Our administrator, Victor Mendez, was originally scheduled to be here, but in the end, the scheduling just didn't work out. He sends his greetings and his regrets for not being able to be here. On behalf of FHWA, I'd like to discuss several aspects of the connected vehicle technology that we're currently working with in conjunction with RETA and the other modes. And let me start with talking a little bit more about V2I for safety. As was mentioned, the DSRC connection is important for V2V applications. It's also the enabling technology that will allow us to get into V2I. And for example, if you think about the ability to provide a warning to a driver who's about to take a curve too quickly, a warning of a closed lane ahead, flash flooding, icy roads, large vehicles approaching a structure that's too low. Those are all applications that could take advantage of V2I technology, and we are working on those sorts of scenarios and other scenarios that would enable us to take advantage of that capability as a complement to the vehicle-to-vehicle work. Bill mentioned the Smart Roadside Initiative. We're very excited about working on that project with Federal Motor Carrier Safety Administration. It's another great V2I safety application. We're also working with the traffic signal controller manufacturer industry on working with them on being able to upgrade their controllers so that they can broadcast some basic signal timing information that vehicles could potentially take advantage of, the basic signal phase and timing information. And that information, along with the basic safety information that vehicles will have at their disposal, could lead to a lot of interesting and exciting safety applications. So there's a lot of work that's underway that FHWA is participating in the V2I area. In addition to the V2I work, we continue to work on infrastructure applications that are infrastructure-based systems, such as the work we have underway on the dynamic stop sign assist project that Minnesota DOT is evaluating. It's strictly an infrastructure-based system, detection done in the infrastructure, information displayed back to the driver through the infrastructure. And we're going to continue to research some of those solutions because we think they are a good complement to V2I and V2V safety applications, and we're going to need to continue to invest in those until there's a deep market penetration of the DSRC technology in vehicles. We're also working on quite a bit on mobility and environmental applications that will use V2I communications. We see tremendous potential for the use of data from connected vehicles in a transportation management setting, making decisions on operations, making decisions during bad weather, and to develop and to use those mobility applications, we need access to the same kind of information from the vehicle that will be used in V2V and V2I safety applications. So we're working closely with NHTSA and with RITA to make sure that we have access to that information for those purposes. Greg mentioned the security network and the need to have a security network to enable secure and anonymous communications for V2V and V2I. And I wanted to talk about that just for a second because I think it's been an area that has been a little bit misunderstood that goes all the way back to the beginning of the V2I or VII program. Got too many V's and too many I's in our history here. In the early stages of the VII program, we made some assumptions, as you have to do when you're doing research, and we had assumed that DSRC was going to be the communications method that we were going to use for all of the applications and all of the communications in what we now know as the Connected Vehicle Program. And we learned a lot. We learned a lot about how that might work. We learned a lot about some of the issues we would have to overcome. And today we're in a new place in that research. We understand that DSRC is necessary for V2V and V2I safety applications. There's no question about that. DSRC isn't required necessarily for the security network. And so some of the assumptions that we made about having large numbers of roadside infrastructure for a security network may or may not still be valid. So we are looking at now 3 options for addressing the security question. DSRC is one of those options, perhaps installed by state and local governments, perhaps not. That's one of the issues we need to look at. We're looking at use of existing cellular networks, and we're looking at a V2V approach that wouldn't rely on infrastructure at all. It would be strictly between vehicle communications. It's important to understand that while I say there's 3 options, and you can list them quickly, there's a lot of technical and institutional and policy issues that have to be studied and evaluated before we can make a decision. You know, we know that state budgets are very tight, so a solution that relies heavily on infrastructure, how we get that into place and operated and maintained, that's an issue. If we go more on the cellular side, there's some privacy concerns with cellular that we're going to have to work out. But we have to get to a security network solution if we're going to get to the decision that NHTSA wants to make in 2013. So USDOT is committing and is committed to a major milestone by the end of next summer to complete the technical work on the security network. We're going to figure out what the right decision is, and we're going to make that decision by the end of next summer, so stay tuned on that. And the last thing I wanted to mention was just a couple of things about what we're doing that is related to the connected vehicle work, but sort of outside of that work as well, that we're working with ITS technology in order to address mobility challenges in particular. You know, there's been a lot of ITS technology that's been deployed in the last 20 years, from traffic signal advances to ramp metering to multimodal travel information systems. If you look back over the history of the ITS program, there has been a lot that's happened. ITS technologies help gauge how well transportation systems are performing by measuring the flow of people, traffic, and goods. Road weather information systems have become prevalent, helping to determine travel conditions and improving forecasting of future conditions. You know, we had a few events here a couple of months back, or maybe shorter than that, maybe only about 6 weeks ago. Over a 2-week period on the East Coast, we had an earthquake, we had a hurricane, and we had some torrential flooding that closed a number of our roadway facilities. And we found out that traveler information is really important under those circumstances. And we also found out that the East Coast and the I-95 corridor have a lot of really good technology and really good systems in place that they were able to take advantage of during those conditions. And a lot of that technology and those systems were funded through the ITS program. For instance, the Probe Vehicle project funded by the I-95 Corridor Coalition. We're still working in active traffic management. We've got a couple of places in the U.S. that have deployed active traffic management systems in Seattle and Minneapolis that seek to deploy things like speed harmonization, variable speed limits, lane use controls, hard shoulder running, things that we've adopted from some very successful experience in Europe. We continue our integrated corridor management initiative, which is focused on some demonstrations in San Diego and in Dallas. In Dallas, the folks there are going to use a travel model to predict traffic conditions 30 minutes into the future so that they can be more proactive about diverting traffic on US 75 during incidents, during special events, and when there are good alternatives. And in San Diego, the I-15 corridor, they're doing the same, not the predictive part, but the same, using the same sort of technology to get folks onto the right facility and into the right mode, onto HOV lanes, onto transit, into the high occupancy toll lane that exists there. And it's really, really some exciting stuff. I could go on. There's some other really cool stuff that we're working on in congestion pricing and adaptive traffic signal control, but I think my time's about up. Many of these topics are being covered during sessions during the Congress. I'd encourage you to take a close look at the program and see where a lot of the things that I've talked about this morning are being covered, and to learn more about them. I'll be here through Thursday afternoon, and I'd be happy to chat further with you about what FHWA is doing in ITS and to answer any questions that you might have. Thanks again for the opportunity to share with you.